Guys, you hungry?
Yeah, so hungry.
Oh,
Sure. Let me double check that.
Actually, do you want to eat pizza?
sure, yes. That sounds like a good idea.
Let me see. What do you want to order?
What about like no veggies, just like
The pepperoni.
yeah.
Okay, pepperoni?
Yes.
Okay, I'll order it.
Thanks.
One eternity later.
Still not here? So long already.
Yeah,
So hungry.
I feel like just order some.
No, it's okay. Don't spill the appetite. They'll come here soon, I guess.
Eventually.
It's here already, guys. I got it.
Yay, finally. And this is your pizza delivery.
Thank you. Guys, pizza's here. It's cold.
Yeah.
I don't want it anymore.
Okay, I'm so sorry about that. We'll give you $10 voucher as compensation. I'm really sorry. Okay, I'm so sorry about that. We'll give you a $10 voucher in compensation. I understand that. Hey, what's going on? Well, we just had a customer call again about a cold pizza. It's the 5th call today.
Yeah, so I don't think we can keep compensating the customers. It's costing us a lot of money. I think we have to think of a better solution.
Have you ever waited for your pizza delivery, only to be utterly disappointed when it finally arrives? You just spent $20 to $30, waited for an hour or so, just to receive a pizza that's already stale and cold. And now you're forcing yourself to eat it just because you've already spent the money and you don't want it to go to waste. If this sounds familiar, we feel your pain. But fret not, because my team and I are here today to save the day. We will devise a solution so that all you pizza lovers no longer have to experience that ever again. But in order to do so, we have to make use of statistics to find out how long it takes for a pizza to lose its freshness. This would be denoted by the time taken for a pizza to reach room temperature from the time it's taken out from the oven all the way till it reaches your doorstep.
We took our data of daily temperatures from the website AccuWeather for over a 3-month period. As with regards to the temperature and type of each pizza dished out, we procure 3 months of information on the type of pizza sold and the temperature at which the pizza was at for when it was about to enter the delivery bag.
According to our research and a survey we conducted with 100 students in NTU, we found that people find pizza no longer fresh when the temperature of the pizza reaches room temperature, which is 26 degrees Celsius. In our research, we want to investigate if weather is a significant variable in affecting the cool down time of a pizza, which is the time taken for the pizza to reach 26 degrees Celsius. Hence, our H0 is beta equals to 0, which means that weather is significant, and our alternative hypothesis, which is H1, is beta is not equals to 0, which means that weather is not significant. We then collected data from several students in NTU and ensured that they are unrelated to each other. This ensures that our sampling data follows the independent and identically distributed rule. To test our hypothesis, we will load our data files into RStudio and generate a regression model.
For our regression model, we have decided that our dependent variable would be the cooldown time. Our 3 independent variables which affect the cooldown time are thickness of pizza, temperature of pizza before it enters the delivery bag, as well as the weather. However, this list is not exhaustive, and there are many other variables affecting the cooldown time, but we would deem these variables as negligible. We then collected data on these 3 independent variables. After we ran the regression analysis, we have concluded that weather is a significant factor influencing cooldown time. This can be seen from the 3-star significance that was shown in the result of the regression analysis for all 3 weather types. This thus proves that H0 is true. Furthermore, out of all the 3 weather conditions, rainy weather affected cooldown time the most. This is because the p-value of temp rainy was the smallest as compared to temp sunny and temp cloudy. Hence, since the smaller p-value, the higher the significance of the factor, rainy weather is the most significant factor affecting the cooldown time of the pizza.
Given that the pizza would lose its freshness after reaching room temperature, we want to show how long it takes for the pizza to cool down to 26 degrees. We will be doing this by calculating the confidence interval with the cool down timings for all three weather types. In this case, we will be using the confidence level of 95%, and by taking the lower limit, we would determine the shortest timing that the pizza cools down to room temperature. By utilizing the t-test function in R, we found that the cooldown times for sunny, cloudy, and raining weather conditions is between 32.49 and 34.17, 27.01 and 28.5, and 12.36 and 13.71, 90% of the time respectively. This once again shows that the rainy weather would have the greatest impact on the cooldown timing of the pizza. From this, our solution should then focus on delivering the pizza to the customers within the lower limit timings, whereby lessening the time that the pizza can be kept warm, such that the pizza would not lose its freshness when it reaches the customers.
Introducing Pizza Proof. The Pizza Proof is an insulating wrap that is lightweight, cheap, and keeps the pizza warm for a long amount of time after it's out of the oven. We have come up with a solution to ensure that your pizzas are no longer cold or stale. Depending on the weather conditions for that particular day, select the appropriate version of the Pizza Proof. Now simply wrap the box with the Pizza Proof right when it's fresh out of the oven to ensure that the pizza stays warmer for a longer period of time, despite the weather conditions for that particular day. This ensures that the customers will receive the fresh pizzas upon delivery despite the harsh weather conditions.
Simply wrap the pizzas with the Pizza Proof to keep the pizzas warmer for longer. Our three versions include the light version for sunny weather, the regular version for cloudy weather, and the deluxe version for rainy weather conditions. Engineered and created using different materials with different insulating properties, this ensures that customers will receive fresh pizzas upon delivery despite the harsh weather conditions.
Guys, I'm hungry again. You want to order pizza?
But I don't want to eat cold stale pizza again.
But then I heard Pizza Hut found a new way to solve this issue. I think we won't face the same problem again.
Okay, fine. But if the pizza is cold the next time, then I'm never ordering pizza again.
Later.
Huh? What's this? Guys, pizza's here.
It's warm.
It's warm. Pizza proof.